Welcome back. Today we're going to look at section 3.1, which is on relations and functions. There's quite a bit of information here, so we're going to split this up into two videos. So for the first video, part 1, we'll do the first 4 pages of notes, which goes through using function notation. And then I'll do a part 2 video for this section for the remaining few objectives, just so that the videos are not so long, or if you need to take a break. Okay? All right, so this first part of section 3.1, we're going to talk about relations, functions, and functions notation. So at the top of the notes page, which again, hopefully you've printed out and you're working along with me, you'll see some definitions and then a few things to fill in the blanks with. So let's look over that. In algebra, we say that a relation is any set of ordered pairs. So you can make a set of ordered pairs of anything. They don't have to be numbers. They could be, people's birth dates to the month. They could be your favorite color and the person's name. So a relation can really be anything. But typically in algebra, we're going to be working with the number side of that, okay? So it says it's any set of ordered pairs will automatically relate the set of the first coordinate to the set of the second coordinates. And those sets have special names. So the set of first coordinates in a relation is called a domain, okay? So the domain of any relation is always just all of the sets of the first coordinates. And on the same side of that, then the range would be the second set of all of the second coordinates. I think I said second set. So the range of a relation is a set that includes all of the second coordinates of your relation. Okay? All right, so if you look at a domain and a range and a relation, then we can even kind of go into a tighter group, which are called functions. Okay? So first off, in the scheme of things, a relation could be any set of ordered pairs. There's really no limit on those. But if you're asked about functions, then it's a specific kind of relation. Okay? So the definition for function says a relation is a function if and only if each element in the domain, so we're going to fill that in, is paired with exactly one element in the range. Okay? A lot of students get this confused, so I try to just make this as simple as I can. When you're looking to see if something's a function, you want to check and make sure that all the x values are different. Okay? There's several ways to do that, so that's part of what we're going to do right now is talk about all the different ways that we can tell whether or not a relation is a function. All right, also, to be a function, here's just some little keys for you. You must be able to solve for y. Okay, so in order to be a function, typically you should be able to solve the equation for y if you're given an equation. The y value cannot have an even exponent associated with it. That's important, the word even there. Okay, so y squared, y to the fourth, y to the sixth, those will not be functions. You don't even have to worry about those. Y cubed, y to the fifth, that's a different story. Those are okay. So it has to be an even exponent. It cannot have an even exponent. Okay. All right, so we're going to go through and look at lots of different ways you might be given these kind of questions. So let's look at the first group. It says state the domain and range of each of the following relations and then determine if it's a function. All right, so I'm going to just use a capital D for the domain. So the domain is the set of the first coordinates in here. So I would say 3, -3, -4, 1, and then the last number is 3. So I've already got it listed here, so I don't have to do that again. Okay. The range, all the second coordinates, so 7, 2, 5, 4, -4. So that's how I would list them. I don't really care that they're in order or not. Sometimes you're asked to put them in, increasing order. For me, that's not a problem. All right, now, is this a function? To be a function, each x has to be paired with exactly one y. So can't use an x value twice. I can't have an x going to two different y's. So in this case, this is not a function because I have 3 going to 7, and I also have 3 going to -4. Okay, so this is not a function. All the x's are not different. Okay, let's look at number 2. The domain, the set of all the first coordinates, -1, 0, 1, 2, 3. And the range, the set of all the y coordinates, 2, don't need to list it again, 5, 3, and 2 is already listed. So that's that. Is this a function? Yes, it is. Okay, all the x's are different. The y's for a function don't matter. I can have a same y value as many times as I want. I just cannot repeat the x's. Okay, it has to be a function. So this one is a function because all the x's are different. All right, so that's just looking at a set of ordered pairs. Now let's look at equations. Determine whether the given equation is a function. So remember, in order to do that, you have to be able to solve for y, and y's can't have an even exponent. So for number 3, I can solve that for y. Okay, so I already know this is a yes question, but we're going to have to solve anyway, so let's refresh our memory on that. So if I wanted to solve this for y, first thing I would do is subtract the 3x over to the other side. Remember, when you move over the equal sign, you're changing the sign. And then I'm going to divide everything by -2. So if you divide everything by -2, -2 divided by -2 is y. -3 divided by -2 will give you a +3/2. And -12 divided by -2 gives you a +6. So I was able to solve for y, so this is a function. Okay. All right, look at number 4. Number 4 already says y equals. So I solve for y. It's already done for me. So this is a function. I don't have to do anything with that one. So anytime an equation is solved for y, that's kind of nice for you. You'll know that's a function already. All right, the last one, number 5, if you notice, has a y squared in it. If it has an even power of y, not x, but only if y has an even power, that's not going to be a function. Excuse me. So if you look at this problem, and I could solve it for y, but it's not going to be a function. Okay, so I'm going to circle that right here. This is not a function, so I don't really need to do anything else. I just noticed that there's an even power for y, so that's not a function. All right, so that's how you kind of look at equations and can tell. Okay. All right, so now a little bit about function notation. All right, so on that last page we were solving for y. And if you solve for y, then you have a function. Well, sometimes you're going to be given functions that don't start with y, they use function notation. Okay, so that's what this is about. So up at the top of page 2, it says function notation is the way a function is written. It is meant to be a precise way of giving information about the function without a rather lengthy written explanation. So it's kind of shortcut. Okay, it's like you writing LOL or, you know, BTW, whatever. When you write, those are abbreviations, sort of. So this kind of does the same thing. So the most popular function notation is this notation right here, which is f of x. Okay, it's not f times x. You read that f of x. That is function notation. And if I'm going to jump down here and look, because hopefully you remember in algebra, you can replace y with f of x. Those are the same thing. So where we solved for y before, I can replace that with function notation. So you might be saying, well, why is that shortcut? That's a lot smaller to write than f of x. Well, that's true for algebra equations, but when we're looking at real life problems, you'll see in probably, I think, the next section, we'll see how that kind of comes into play, okay? All right, so function notation accomplishes a number of things at once. It gives a name to the function being defined. So in this case, it would be function f, okay? So the letter out front is the name of the function. So it could be g of x, h of x, so whatever that letter is, that is the name of the function. It provides a formula to work with when using the function, and it makes the solving of many, many math problems easier. Okay, so you know where to put numbers when you work with functions. So writing a function in function notation simply means solving the given equation for y, and then we'll substitute in the f of x. So we already did that on the last page. So let's look at number 6. It says rewrite each of the following functions using function notation. And by the way, as we go through these sections, you'll sometimes hear things about the independent or dependent variable. So always remember in math that the independent variable is always x. In other words, that could be anything you want. And then the dependent variable y is based on whatever x is. So the book is going to give you, or the problem will give you a value for x, so that means it's independent. And then you plug x into the problem, you work out, and you solve for y. So y will depend on what x is, so that makes y the dependent variable. Okay. All right, so let's solve number 6 for y. So the first thing I'm going to do is subtract the 3x over to the other side. So leave the negative y there. It gives me negative 3x plus 5. Moving the 3x over, remember it becomes negative. And now you're going to divide everything by negative 1. So negative y divided by negative 1 is y. Negative 3 divided by negative 1 is positive 3, and 5 divided by negative 1 is minus 5, or negative 5. All right, so that's solved for y. So function notation would be to replace this y with the function notation. So f of x equals 3x minus 5. Okay, so these are the same. It's just this is, and a lot of times I'll tell students, this is much better because right now I know this is a function, right? I mean, it says f of x, that's function notation, so that means this has to be a function. Okay, over here where it just says y, or this problem, I don't necessarily know it is until I can make sure I solve for y. But if you're given something like this, then you already know that. Okay. All right, number 7, solve that one. So we're going to move the 2x over. Leave that negative 3y there, which equals negative 2x plus 12. Divide everything by negative 3. So negative 3 divided by negative 3 is 1, so you get y. Negative 2 divided by negative 3 is a positive 2/3. And 12 divided by negative 3 is a negative 4. So there's your equation solved for y. Writing it in function notation, just substitute f of x for y. So f of x equals 2/3 x minus 4. Okay. All right, now if you look at number 8, y has an exponent, but that exponent is y cubed, which is perfectly legal. Okay, that's not an even exponent. That's an even exponent, but remember, that doesn't matter for x. What matters for functions is y has to be an odd exponent. All right, so we're going to solve for y. So I'm going to do this in one step. I'm going to move the 6 over. Well, now I'll do it in 2. And I'll take that back. So let's move the 6 over here. So we're going to subtract 6 from both sides. So that'll give me a 5 over here. So I'm going to leave the negative 5x squared, leave the positive y cubed, and I'm going to move this 6 over, which is positive here. Okay, that minus sign goes with the 5. Remember, the sign in front of the number is the sign of the number. So this is a positive 6. So when we move it over here, it's going to become a minus 6. So 11 minus 6 is 5. All right, now we're going to move the negative 5x squared over, so it's going to become positive. Leave the y cubed there. Okay, and right here, some of you are going to ask, why can't I write 5 plus 5x squared? Why don't I put this at the end? You can. There's nothing wrong with that. But remember, in algebra, typically we write our exponents so that they go down in order, right? That's just a standard form. So I always put the higher exponents in the front. All right, so now we got y cubed. So how do I solve for y cubed? You'll take the cube root of both sides. Okay, so to solve for y, to undo cubing, you would do cube root. Remember the inverse of that. So we're going to take I'll write it here, we're going to take the cube root of this side and the cube root of that side. Okay, that's how we would solve. So this undoes that, just like squaring a square root, right? So that undoes that, leaves you y. And then over here, we're ending up with the cube root of 5x squared plus 5. So there's your function. So we can replace the y with that notation and have the cube root of 5x squared plus 5. Okay, so that's function notation. So anytime you can solve something for y, then you can rewrite it using the f of x notation. Now, there's no function in here, so I mean I could call this g of x, h of x, like I said. This is just the standard. So when you're not given a letter, usually you just let it be f. Okay? Doesn't have to be, but that's just typical. All right, the next thing we're going to go over is making sure you remember how to evaluate. So we're going to start off kind of easy and work our way to a little bit harder stuff, which is going to lead us into this last page of this first part, the difference quotient, okay, which is all about evaluating. Okay, so if we look at number 9, we're given a function, f of x equals x squared plus x minus 1. And we want to find these values, okay? So remember, evaluate means you're solving for something. You're going to give an answer. The answer could be a number or it could have variables in it, okay? So if this is the function, remember, these are the x values, and then f of x is in place of what y equals. So I'm going to write this over here. So remember that f of x equals y, right? Same thing. So so whatever number is in here is your x value, and then when you plug in those x values and work this side out, then that becomes the answer, which is your y, okay? So if we look at f of 4, we're going to write it. So what this means is instead of an x over here, it wants you to put a 4 in here, okay? So it's replacing this x with the 4. So that means I got to replace these x's with a 4. So that's 4 squared plus 4 minus 1. Now just watch your order of operations or use your calculator. So 4 squared is 16 plus 4 minus 1. 16 plus 4 is 20. 20 minus 1 is 19. Okay? So that's just standard, plugging a number into the function. All right, now let's look at part B. F of 3x squared. All right, so look, that was x, and now it's 3x squared. So in here, I'm going to put a 3x squared everywhere I see an x. So I've got 3x squared plus 3x squared minus 1. So remember, this was an x and this was an x. But now this problem is telling you to put in 3x squared. I put it in parentheses, otherwise sometimes you guys forget, because when you're squaring a whole term, you got to square everything. So 3x squared squared means square 3 and square the x squared. So 3 squared is 3 times 3, which is 9, and x squared squared, you multiply your exponents, that's x to the 4th, plus 3x squared minus 1. And that's it. That's all I can do for this problem because there's no other like terms to add together. So there's your answer. Okay, so that's what I mean by sometimes you'll get a numerical answer, sometimes you'll get an algebra polynomial that has variables in it. So it kind of depends on what you're putting into the function. All right, so C, getting a little bit harder. Okay, we're going to plug 2a plus 5 now in place of x. So anything that's in this parentheses is what you're putting in place of x. All right, so instead of this x, I'm going to put in 2a plus 5. so I got to square it because that was squared, plus, instead of this x, I'm going to put in 2a plus 5, and then I had that minus 1 at the end, so forget about that. So now my answers are going to have a's in them, and I've lost all the x's because notice what I'm putting in here. I'm substituting in this value, 2a plus 5, for any x in the problem. All right, so we're going to have to FOIL this out. 2a plus 5 squared means 2a plus 5 times 2a plus 5. So I'm going to write that here. I won't do this a lot, but since we're just starting, okay, that's what squared means. 2a plus 5 times 2a plus 5. I'm going to leave the rest alone for a minute. So you have to FOIL this, okay? First, outer, inner, last, right? So be very careful. When you square a polynomial, you don't just say 2a squared and 5 squared. That will give you the wrong answer. You have to multiply. All right, so first, if we do FOIL, 2a times 2a. Some of you do the lattice, the box method. That's fine. So 2a times 2a is 4a squared. That's the first term. Now we're going to do the outer and the inner, because when you FOIL, remember those are going to usually add together. So the outer two terms is 2a times 5, which is 10a. And then the inside terms, 5 times 2a, is another 10a. So we've got 10a plus 10a, which is 20a. And then last, 5 times 5, that's 25. All right, I'm going to get rid of these parentheses. There's nothing to do with those, so I can write it like that. Now, so last step is to look at all of my terms and add the like ones together. So all I have is 4a squared. I don't have any other a squared, so that's together. I have a positive 20a and a positive 2a, which is positive 22a. And then I have 25 plus 5 minus 1. So 25 plus 5 is 30. 30 minus 1 is 29. So there's our answer. Okay? All right. Now, so that I can see part D and the problem, I'm going to rewrite the problem over here. You don't have to do that, but just so that I can point to it. So here's the original problem, right? So now I don't have to keep going up to the top. All right, so here was the original problem. So now I've got to find f of x plus h. So again, what does that mean? So in place of these x's, whatever is in the parentheses, you are going to put in place of the x's, always, 100% of the time. So I'm going to put an x plus h here and an x plus h here. So that would look like x plus h squared, right? I'm substituting an x plus h here, plus, and then I'm going to put another x plus h, and then minus 1. I like to put things in parentheses when there's more than one term or a big term, because that way you can actually see that you put it in place of that. All right, so the same thing here, we're going to FOIL, okay, that's x plus h times x plus h. That's what squared means. Then we'll do the x plus h and then minus 1. So we're going to FOIL first, just like we did above. First, outer, inner, last. So first, x times x, x squared. Outer is an xh, and inner is also an xh. So we have one xh on the outside, one xh on the inside. So that gives you two xh's, not x squared, h squared. Okay, one xh plus another xh is two xh's. And then last, h times h is x squared. I think I said x, is h squared if I didn't say that. All right, and then I can get rid of the parentheses now, nothing to multiply by there. All right, so again, you're just going to go through and look at what you can add together, if anything. Now, I don't see anything here. I don't have another x squared. I don't have any xh's. Nope, all those terms are separate. They're not like terms at all. So there we go. All right. Now, if I look at part E, I'm going to do f of x plus h minus f of x. Okay? So there's two functions, two things I've got to replace here. So first thing I'm going to do is f of x plus h, which I actually just did. Okay? But let's go over that. So this piece right here means take x plus h and put it in here. So I'm just going to write that down like we did earlier. So x plus h squared plus x plus h minus 1. Okay? And I'm going to put this in brackets because that's this first piece right there. Okay, so take a look at that. That's what we did. We just did it right there. So just this piece is, I put an x plus h here, and I put an x plus h here. Okay, so that's this piece. Now it says minus f of x. Well, what is f of x? That means put an x in here, which is what it is. That is f of x. So it wants us to subtract this function. So minus x squared plus x minus 1. Now this is real important for a lot of you guys. When you are subtracting the entire function, remember you have to subtract everything, which means those signs are going to change. So it's real important, always, and I will stress this, when you do subtraction, always put what comes after that minus sign in parentheses to help you remember that you've got to make all of these minus, which means you're going to be changing all of those signs. Okay? All right, so that's what it looks like. Now, if I hadn't done this already, I would have to do it now, but I am not going to do this again. I already did it, and here's what we got, right? So I already know that what I have right here in the brackets is what's in the box there. That's exactly what we did up above. So I'm just going to write this down here. So this is, I'm just going to bring it down here for this first part. Okay, so x squared plus 2xh plus h squared plus x plus h minus 1. So that's that part right there. Now, we're going to go through and subtract each of these. So that means the signs will change. So this will be minus x squared minus x plus 1. Okay? That's confusing for you. Remember, there's an imaginary 1 here. So you got negative 1 times this, negative 1 times this, negative 1 times this. That's really what we're doing. That's what that minus sign means. We've got to bring it through. Okay, so it's going to be a minus x squared minus x plus 1. Now I do have some things that will cancel out. Okay, so we're not done yet. So I have an x squared and a minus x squared. Those are like terms. They're going to cancel out. That's 0. I have a 2xh, and I don't see another xh term, so that's it. I have an h squared. I don't see another h squared term, so that's it. Now I have a positive x here and a negative x here. That's 0. Those are your like terms. H, I don't see another h term. And then you have a negative 1 and a positive 1, which is also 0. So that's what you're left with. And that would be the final evaluating answer that you would have. Okay? Now, the reason why we gave you part D and E is because of what's on the last page of this first part of your notes, and that is the difference quotient. So if you understand what we did here, and you understand what we did here, the next page adds one more piece to this. So this is actually part of this formula we're getting ready to do. Okay? So typically on just an evaluating problem on Hawks, you're going to be just given ones more like A, B, and C. But for the difference quotient, you'll be given ones that are coming up on the next page. All right. So here we have our little block for writing the difference quotient. You do need to know all your formulas in pre-calc. You don't get a formula sheet. You can't use your formulas in your notes and your book for tests and things. So you do have to memorize these. And I will tell you, there's quite a few formulas and things that you guys need to know. Hopefully you know some of them already. But if not, I would say maybe write them on index cards or write them on a piece of paper so that you can kind of keep up with them as you go, you know, for each test. And then also by the time you get to the final exam, you're going to need to know all of those. The department rule is that you guys do not get formulas, so that is what we stick with. Okay, so please make sure of that. Learn them along the way so you don't have to learn them all at the end. All right, so this is our first real formula, I guess, that we've had. So the different, well, I take that back. I mean, you had several formulas for linear equations, right? Slope-intercept form, the formula to find the slope, all of those are formulas. So if you need to write those down, then again, keep a list of all of them as we go through the course so you have them, or at least the ones that you don't know yet and you need to learn. All right, so difference quotient is what we call in math the average rate of change. Okay, it's the formula to find that. So is the average rate of change of a function within a certain interval. So, you know, find the average rate of change between x equals 1 and when x equals 7. Or find the rate of change when x goes from 1 to 2. So it's a how much is the problem changing? That's kind of what this is about, and we call it a difference quotient if there's a formula. All right, so the difference quotient formula is exactly what we did on the last page plus one little thing. So if you remember that, that would be good here. So we did f of x plus h minus f of x, right? Do you remember that? That was from the page before. And then all we're going to do to add to the difference quotient is we divide it by h. Okay, that is the formula for the difference quotient. So if you're asked to find the difference quotient, this is what you got to do. So it's a little time consuming, but the good news is that they're very similar. So once you get the hang of it, then hopefully you're going to be able to get all the answers correct. So just practice. I'm going to do 2 with you right now. You need more practice, then you're going to practice some more. Now, one of the things that I always tell students, because I see this a lot, some students will put a minus sign here. So remember that it's a difference quotient. Difference means subtract. And where you're subtracting is here. You're subtracting this function from this function. So this is where the minus sign goes, the difference of these two things. And then I always remember, you know, try to learn little tricks to help you with memorizing things. If this is the minus, then this is the opposite sign. So that's the plus sign. Okay, you wouldn't have 2 minuses or 2 pluses. So the difference goes here, and then that makes that one the plus. Okay? All right, so if you've got that memorized, then you can work your formulas, work the problems. So 10 and 11 ask you to find the difference quotient. So that's what we're going to do. We're going to substitute in, okay, this formula into using this problem. All right, so I'm going to just put DQ for difference quotient. Okay. So the difference quotient says, remember, start with the function you're given, and in place of all the x's, you're going to put in this piece. So think of this in 3 parts. This is part 1, part 2, part 3. Okay, 3 pieces. So forget about this right now. So if I just asked you to do f of x plus h, that would mean substitute in x plus h for these 2 x's, right? That's what we've been doing. So that's what I'm going to do. I'm going to put an x plus h, and square it, and then minus 4x plus h, okay? So that's all that this means. So every time you do a problem, think of this in 3 parts. So we're going to take x plus h and put it in anywhere there's an x in my problem. Done. Now, I like to put that in brackets because that's part 1, okay? Minus. Part 2 is just to subtract the function. Remember what that means. F of x is already given to you right here. So we're just going to put that back here, but remember to put it in parentheses because you're going to change all the signs, right? Because of that minus. So that's this piece right there. There's the function. I'm subtracting the function. And then the third piece is to divide that whole thing by h. So that's the new piece that we didn't do on the other page. All right, so I'm going to do what's in here first, and then we got to change the signs, and then we're going to divide everything by h. Okay, so it's very similar no matter what problem you do. All right, now x plus h squared, you're going to do that kind of a lot. So I'm not going to go through the steps with you again, but I'm just going to remind you on the page before. Remember we did x plus h squared. We FOILed it, and we got this. Okay? So I'm just going to use this now. I'm not going to keep doing it over and over again. So anytime you see an x plus h squared, I know that that's the answer. This x squared plus 2x plus h. Just that part right there. Okay? We FOILed it, and we got that. Okay? So that's what I'm getting ready to do on this page. So x plus h squared is x squared plus 2xh plus h squared. Know that. All right, now minus 4 times x plus h. So this is a distributive property. So we're going to do negative 4 times x, negative 4 times h. So negative 4 times x is negative 4x. Negative 4 times h is negative 4h. And then remember, this means change all the signs. What's back here? So minus x squared plus 4x. Okay, remember there's that 1 there. So negative 1 times x squared is negative x squared. Negative 1 times negative 4 is that positive 4x. And then we're dividing everything by h. All right, so before you divide by h, let's cancel the things that will cancel. You're always going to have a couple of things cancel here. So x squared minus x squared is going to cancel. Negative 4x plus 4x will cancel. So now we have 2xh plus h squared minus 4h. These are the terms that are left. That term's left, that term's left, that term's left. So those are the 3 terms that are left. Now I'm going to divide each of those by h. Okay? All right, so you can do this one of 2 ways. I'm going to do it by factoring. I think that's probably easier so you don't mess up. But as long as you know you got to take an h out of each of these terms, then that's fine. You could do it that way. I'm going to do one other step and factor the h out because each of these terms has an h in them. So if I factor one h out from each term, so if I take the h out of here, that leaves me 2x. If I take one h out of here, that leaves me 1h. If I take the h out of there, it leaves me minus 4. Okay, and now if you do that, then you just cancel that h, and you end up with what's left, which is your answer. So that is the difference quotient for this problem. Okay, and your difference quotient usually always has x's and h's left in it. So it's just kind of a good way to remember it. So if this is confusing to you, okay, then if I just skip this step and just look over here and say, all right, if I take an h out of here, that leaves me 2x. There it is. If you take an h out of here, that leaves you h. There it is. And if you take the h out of this one, that leaves you the minus 4. So you don't have to do the factor step. It just kind of depends on which way you like to do it. All right. So now let's look at the last one of difference quotient. Okay, same type of problem, just one's a little bit harder because of the 3 out front. So a little bit more work to do. Okay, so let's remember the difference quotient. We're going to take the original problem and just everywhere there's an x, you're going to substitute in x plus h. Okay, so take the original problem and anywhere there's an x, you're going to put in x plus h. So 3x plus h squared plus 2x plus h minus 5. So everywhere there was an x, I substituted in x plus h. That's part 1. Okay, always. Okay, part 1. That's it. Part 2 is to subtract the original function. Put it in parentheses. So minus f of x, which is now this. So minus 3x squared plus 2x minus 5. And then you're going to divide all of that by h. Okay, so we got a little bit of work to do on this one. So remember your order of operations. You always want to do squares first, right? Powers come first. So that's the first thing I'm going to do. I'm not going to do anything else with this problem except square x plus h, which, remember I told you, we're going to just always write this here. That's x plus h squared. I'm not going to do anything else on this part. So I'm going to leave the bracket. I'm going to leave the 3. And now I'm going to do my square. X plus h squared is x squared plus 2xh plus h squared. Okay, it's always going to be that. So we know that. Leave everything else the way it is for a minute. I just like to do this in steps so that you guys, if you go back, you can look at this and see it. So I'm not changing anything else. Some of you like to do several steps at one time, and then you lose things, and then you get things wrong. So just one step at a time. So order of operations, the first thing you always do is powers. So that's what I did. Okay, now I can multiply. Okay, now I can multiply. So I'm going to multiply 3 times each of these. I'm going to multiply 2 times each of these. And then I've got, remember that -1 here, so I'm going to multiply by that and change those signs. So I'm going to do all that now. So it's a long problem, so you just got to watch your steps and watch your signs. So 3 times x squared is 3x squared. 3 times 2xh is 6xh. 3 times h squared, 3h squared. Okay, now I'm going to do 2 times x plus h, so 2 times x is 2x. 2 times h is 2h minus 5. And then remember, this means change all the signs because you're multiplying by that -1. So negative 3x squared minus 2x plus 5. And all of that is over h. Okay? All right, so now we're going to see what we can add together, see what cancels out. So let's look at 3x squared. Are there any other x squared terms? Yes, there is, and it's the same but the opposite sign, so those are 0. I've got a 6xh, and I don't have any other xh terms, so 6xh. I have a 3h squared, no other h squared term. I've got a positive 2x, and over here I got a negative 2x. They're going away. 0. I have a positive 2h, no other h term. And then I have a -5 and a positive 5, which will cancel out. Okay? So one little trick to this that I will tell you, since we've done these 2 problems, is if you remember up here, everything that was left after I canceled out had an h in it. That's because I had to be able to cancel the h out of that bottom from each term. So notice down what happened here. What are you left with? You're left with only terms with h in it. So if you end up with a term here that doesn't have an h in it, then that's your clue that you did something wrong. Like what if you ended up with 10 here and put it plus 10 or minus 10? That's not right because you can't take an h out of it. So at this very last step, you have to be able to take h out of each of the terms that are left. Otherwise, you've done something wrong. You made a careless math error. Okay? All right, so again, you can factor out the h. Let's say I'm not going to do this one. I'll do it the other way. So we did one where we factored it out, which if you want to factor the h out, that's great. But you can also just take the h out of each term individually. So if you take the one h out of here, you're left with 6x. If you take one h out of here, remember there's 2 h's in there right now, so that'll leave you with 3 and 1 of the h's. And then if you take this h away, you're left with just the 2. Okay. So like I said, I don't know, if that's better for you or if you did factor out the h. Okay. If you did factor, I'll write it down here for those of you that like the consistency. So if I took an h out of the top, take the h out of there, take one h out of there, take the h out of there, and then you would have canceled those h's, and that's still your same answer. Okay? So, I don't really mind you doing it either way. I just want to make sure you get the right answer. Alrighty? Okay, so learn that difference quotient. Practice these. You can stop here at part 1 and then go do some of your Hawks homework if you'd like. Or if you're feeling it and want to go ahead and continue the rest of these notes, then you can just click on the part 2 video and we'll finish up those last 3 pages. Okay? All right. So until then, you guys keep working hard. Email me if you got any questions.